Hello my dear students, today we are going to discuss about glycogenesis. Okay, what is glycogenesis? Glycogenesis means it is the pathway for the formation of glycogen from glucose. This process requires energy. It is supplied by ATP and UTP. What is UTP? Uridine triphosphate. And this pathway occurs in muscle and liver cytoplasm because glycogen, storage form of glucose, there are two types of glycogen, that is muscle glycogen and liver glycogen. That's why this pathway occurs in muscle and liver cytoplasm. Okay, so we are entering into the pathway. There are three steps for this glycogenesis pathway. The first step is formation of UDPG, second step is known as the action of glycogen synthase, and third step is known as the action of branching enzyme. Okay, then the first step, formation of UDPG. How this UDPG formed? There are three enzymes involved in the formation of UDPG. Glucose is converted to glucose 6-phosphate in presence of glucokinase or hexokinase with the use of ATP. ATP is converted to ADP and glucose is converted to glucose 6-phosphate. And glucose 6-phosphate in presence of an enzyme phosphoglucomutase, it is converted to glucose 1-phosphate. What happens to this glucose 1-phosphate? It is converted to UDP glucose or UDPG in presence of UTP. What is UTP? Uridine triphosphate. This UTP by the addition of glucose 1-phosphate is converted to UDP with the removal of 2-phosphate group. So UTP means UDP plus glucose. Here we have glucose 1-phosphate. So UDP plus glucose combines with glucose 1-phosphate and converted to UDP glucose and PPI is removed. In presence of enzyme UDP glucose pyrophosphorylase. So there are three enzymes. Which are the three enzymes? Glucokinase or hexokinase with the use of ATP, glucose is converted to glucose 6-phosphate. In presence of phosphoglucomutase, glucose 6-phosphate is converted to glucose 1-phosphate. And this glucose 1-phosphate in presence of UDP glucose pyrophosphorylase converted to UDP glucose, and at the same time 2-PPI is released. And what happens to this 2-PPI? What happens to this PPI? It is converted to 2-PI in presence of an enzyme pyrophosphatase. Okay, we can explain once again. Formation of UDPG, glucose is phosphorylated to glucose 6-phosphate by hexokinase in muscle and glucokinase in liver, because there are two types of glycogen. Which are they? Muscle glycogen and liver glycogen. So hexokinase present in muscle and glucokinase present in liver. Then the glucose 6-phosphate is converted to glucose 1-phosphate by the enzyme phosphoglucomutase, and glucose 1-phosphate reacts with UTP, forms our main thing, that is UDP glucose, active form of glucose. UDP glucose is essential for the synthesis of glycogen. The reaction is catalyzed by the enzyme UDP glucose pyrophosphorylase. The enzyme, the name of the enzyme itself, it is used for the formation of UDP glucose and also the release of pyrophosphate. Okay, so the overall reaction can be written like this: glucose 1-phosphate plus UTP is equal to UDP glucose plus PPI in presence of UDP glucose pyrophosphorylase. Okay, that's about the formation of UDPG. Next, the second step, the action of glycogen synthase, and the third step, the action of branching enzyme. So what is the action of glycogen synthase? Here we can see a protein, it is known as glycogenin. It's an oligomer that contain one protein molecule plus it's a glycoprotein. It combines with protein and an oligosaccharide. It is 7 glucose units are associated with a protein. It is known as glycogenin. It is the starting material of glycogenesis. Clear? Glycogenin is the starting material of glycogenesis. It's a oligosaccharide containing 7 glucose units plus 1 protein. Okay, then this glycogenin is the starting material of glycogenesis. What happens to this glycogenin? To this glycogenin, our UDP glucose, we already prepared this UDP glucose in our first step, and this UDP glucose attached to glycogenin, and glucose is attached and UDP is removed. The name of the enzyme involved in this reaction is glycogen synthase. That is the key enzyme of glycogenesis. After many cycles, so many UDP glucose are involved and UDP is removed, glucose is attached. So the length of the molecule will increase. Okay. So here from 7, almost 10 glucose units are get attached with the help of glycogen synthase. Okay. I will explain those steps in detail. Action of glycogen synthase. Glucose moiety from UDP glucose is transferred to a glycogen primer, and this glycogen primer is known as glycogenin molecule. The primer is essential to accept a glucose unit. Primer is made up of a protein carbohydrate complex. It's an oligosaccharide chain of 7 glucose units added to a protein, and which is the activated glucose, our UDPG. So these activated glucose units are sequentially added by the enzyme glycogen synthase. Which is that enzyme glycogen synthase? It is used for the addition of UDPG and removal of UDP by the addition of glucose to glycogenin. The glucose units are added to the non-reducing end of the glycogen primer to form an alpha-1,4 glycosidic linkage, and UDP is liberated. Once again, we can see what happens here. Action of glycogen synthase. This is glycogenin. What is glycogenin? An oligosaccharide plus 1 protein. What is meant by an oligosaccharide? The number of sugar units present in oligosaccharide, almost 3 to 10. So here 7 glucose units plus 1 protein. That material is known as glycogenin. It's a primer for the synthesis of glycogenesis. Then the action of glycogen synthase, the active form of UDP glucose is attached and the removal of UDP occurs, and many cycles occurs. So many UDPG are added and UDP removed, glucose get attached. By which linkage? Alpha-1,4 linkage, because straight chain is formed. There is no branching, only straight chain is involved. So the linkage is known as alpha-1,4 linkage. Okay, then after the formation, up to 10 glucose units added to this glycogenin. What happens to this glycogenin or glycogen primer with 10 glucose unit? Another enzyme, our third enzyme, branching enzyme. The third enzyme is known as branching enzyme. This branching enzyme is used for the branching. It transfers 6 glucose residues to form a new branch. 4 glucose residues are remaining here, this side, and 6 glucose molecules are shifted to this side with 1 linkage. It is known as alpha-1,6 linkage. Here straight chain alpha-1,4 linkage is there. Then branching occurs, the linkage is known as alpha-1,6 linkage. So 4 glucose units are here. Then after 4 glucose residues, 6 shifted to this side. With which linkage? Alpha-1,6 linkage. Okay. So by the repeated action of glycogen synthase and branching enzyme, we can see this glycogen branched structure, straight chain and also branching is there. This compact structure of glycogen is formed by the repeat action of glycogen synthase and branching enzyme. Once again, I will repeat the action of branching enzyme. The glycogen synthase can add glucose units only in which linkage? Alpha-1,4 linkage. Branching enzyme is needed to create alpha-1,6 linkage. When chain is lengthened up to 12 residues, the branching enzyme will transfer a block of 6 to 8 glucose residues from this chain to another site on growing molecule. The enzyme is also known as amylo 1,4,1,6 transglucosidase. Here from 1,4 linkage to 1,6. That's why the name amylo 1,4,1,6 transglucosidase. Branching enzyme forms alpha 1,6 linkage. To this newly created branch, further glucose units can be added in alpha 1,4 linkages by glycogen synthase. Finally, we will get our glycogen molecule. Once again, I will repeat the action of glycogen synthase and branching enzyme. Here we can see glycogen, it's a protein, okay, that contains 7 glucose unit and a protein, and to this protein UDP glucose added and UDP is removed. By the action of glycogen synthase, many cycles are formed. Then after many cycles of reaction, almost 10 glucose units are added to this oligosaccharide and protein glycogen primer. By the action of branching enzyme, then 6 glucose residues are shifted from this side to this side by a linkage. With a linkage, it is attached to the main chain. It is by linkage alpha 1,6. So branching point, which linkage is there? Alpha 1,6. Straight chain, we have alpha 1,4 linkage. By the repeat action of glycogen synthase and branching enzyme, we will get our glycogen structure. That's about our glycogenesis. A very simple process. There are 3 steps of reactions. It is formation of UDPG, action of glycogen synthase, action of branching enzyme. This is the formation of UDPG with 3 enzymes, glucokinase or hexokinase, phosphoglucomutase, UDP glucose pyrophosphorylase. We synthesize UDPG. Then after that, we can synthesize glycogen with 2 more enzymes. Which are the 2 more enzymes? Glycogen synthase and branching enzyme. Branching enzyme is also known as amylo 1,4,1,6 transglucosidase. Here we can remove the linkage alpha 1,4 linkage, and then here we get a linkage. That's why the branching enzyme is known as amylo 1,4,1,6 transglucosidase. Okay, by the repeat action of glycogen synthase and branching enzyme, we get our glycogen. That's about the synthesis of glycogen.